Grade 11s. So today we're looking at networks. It's again term 1 work, so because we've already done it, so we'll quickly revise around it. So on networks in grade 10 we learned about why would we want networks, and that's so that we can share resources, organizing information because the information can be centralized, and connecting people, so communication is very easy and we can communicate with people anywhere in the world very quickly, and then providing access to entertainment for our esports and stuff. Okay, so let's look at overview of physical aspects of a network. So we get two types of communication media, which is either wired or wireless. If we look at our wireless options, we've got Wi-Fi, which is normally in a small range, and you need your access point. Access point is anything sort of like your antenna on your router. Nowadays, if you look at your router in your house, it's actually a lot of devices together or a lot of different technologies coming together. They call that convergent devices. So if you take a look at your router itself, if you've got a router at home, if you look at it, at the back you'll see you can actually plug in 4 or 5 network cables. So that the thing that allows us to do that is actually a small switch that's built into it. So that allows us to create our own internal network. The antenna, the one that actually creates your Wi-Fi area, is called your wireless access point. If you think of our school, those of you that saw it or that remembered on our bridges and across the school, there's like small boxes with also antenna on. That is our access points in our school. So those devices creates our wireless networks, and that allows our staff to move around school and still be able to connect to the network, doesn't matter where they are. WiMAX is like Wi-Fi's bigger brother. It's the same as Wi-Fi, except it's got a much longer range, and it's got safe safety is also, it's much more secure. Okay, they didn't say it yet, but it is much more secure and a longer range. So that's why people would want it, and more devices can connect to it. Then we've got our 4G and 5G. I think all of you know that's like our cell phones that our cell phones can use so that we can connect to the internet and so forth. Okay, so data transmission media. So we've got wired and wireless. We just spoke about the wireless ones. On wired, the two main ones that we're going to look at is our UTP, which is unshielded twisted pair, and our fiber optic cables. That's the two main ones we're going to look at. So if you look UTP, that's our normal one. Sort of looks like an antenna. Looks like an antenna, a telephone connector, and that's our normal ones. Even in our classroom, if you remember our classroom, there's a lot of like gray cables going into that one cabinet. All of them are UTP cables. And we've got fiber optic on this side. You'll see inside this plastic covering, all of this is just to protect this inside thing, which is like a type of glass that's inside there. Our UTP cables actually utilize electrical signals, and there's copper cables inside, while our fiber optic uses like glass wires as such, but it's a type of composite between glass and plastic because it's still a little bit flexible, but not a lot. And then it sends light signals through there. So our fiber optic is much faster. Let's see what they say. Okay, they didn't talk much more. So yeah, so fiber optics much faster than our UTP. Our UTP ones, however, remember, because it's an electrical current going through there, there's actually a magnetic field that goes around. So when we're deciding between different cables, we've got some words we need to look at, which will either make it negative or positive. So the first word is attenuation. Attenuation has to do with the length of the cable. Our UTP cables can go only about 100 meters before you need some sort of a booster or something that's going to boost the signal, because the signal would get too weak to go any further. While when we talk about fiber optic cables, we're talking in kilometers how far it can go. With a fiber optic, it actually depends on the quality of the cable. It can go, some of them goes much further. Those of you that knew that we had like an internet problem 3-4 months ago, and that's because some of the undersea fiber optic cables got damaged, and they had to go fix that. So, and that is our fiber optic. So fiber optic, if you've got a big enough, strong enough cable, you can go very far. As I just said, now this actually connected some continents via undersea cables with fiber optic. But you get also very small ones that you'll have in your house. If you've got a fiber connection in your house, you'd say there's a small thin cable going from your one modem to your router, and that is actually our fiber optic cable. Okay, then we're looking at the physical layout. Okay, we call this the topology. There's 4 topologies you should know about. The first one is the star one. Okay, it looks like this. You've got a central connection. This central one is not necessarily a server. Most of the time it's actually just a switch that connects all the devices to each other. You can read through there. Main problem with this is if our central device breaks, the whole network is down. But a positive of this one, if one of the computers break, everything else can still work and there's no other problems. And if you want to add or remove some of these nodes, you can easily do that without any interruption to the network. So star is the most common one and it's easy to set up. You don't need technical people to do that. You literally just buy a switch, you connect the cables to all your devices, and you've got a star topology. Remember, the physical layout doesn't need to look like this. It just means each device is connected to a central node. Even in my class, it might look like it's another topology, which we'll get to now. Like it looks like a bus one, but every single computer is connected to the central switch. So the topology we use in my class is also a star one, even though it doesn't physically look like it, but the way that the cabling works is a star topology. Okay, and then, oh, they didn't go through the other ones. Okay, so other topologies we've got. Okay, this is the star one. A bus one is if we've got a fiber line that's sort of like in a circle or in a line, and then from that one line, that's called the backbone. From there, it branches off to each device. So each device connects to a central cable that sends the information through, and that's our bus topology. Our third one we've got is a ring topology. That would be if this device connects with this device, and then this one connects with this one, and this one connects with this one with that, this one with that, this one with that. So they're connected like in a circle. There's no central computer, so they're just connected in a circle like that. That's called a ring topology. And then our last one we need to know is our hybrid. A hybrid is a combination between them. So if you look at our school, our classrooms, like the IT lab and the CAT lab, both have got star topologies inside. But if you look at the school as a whole, we've actually got a ring topology running in our school that connects one switch to another switch to another switch to another switch, and they are all connected with fiber lines. And then from there, all the computers branch out. So each of them's got then like a star topology. But then the main backbone of our school is actually a ring topology. The downside of a ring, if one device goes down, the network is actually interrupted. So that's not a good thing about that one. And then for a bus topology, the one with the central line and then everybody connects with it, it's called the backbone. That type of topology, the benefit is sort of the same as this one. If anything breaks, it's fine. The only downside to that one is if your backbone cable is interrupted, then the whole network is down. Okay, so we do have some physical limitations where the speed could be slow depending on the cable you use, but most of the time a cabled solution is always faster than a wireless solution. And then here just some things you should know. So the small k, capital letter B, is a kilobyte, while the small k, small b, is kilobits. So difference between a bit and a byte again, bit is 1. It's either a 1 or a 0. So, but it's 1 digit. While a byte is 8 bits. And then you get sometimes your capital letter MB per S, it's megabits per second, and your KB per S is kilobits per second. That measures the speed in which information is sent over. Okay, each of our connecting devices, they need to have a NIC, network interface card or network interface controller. In a computer, it normally looks something like this, but even in your cell phones and stuff, you've got a built-in device that allows you to connect to a wireless network, and that's also, it's a NIC, it's a network interface controller. Other devices we should know: a modem. The purpose of a modem is to connect the network to the internet, but another purpose, actually the main purpose of a modem, is it changes the type of signal. So it will change your digital signal into a light signal if it needs to be go over fiber optic, or it will change your digital signature into radio waves if it needs to go wireless, and so forth and so forth. So if the type of signal changes, that's thanks to a modem that does that for us. A switch allows multiple devices to connect to the same network. That's the main purpose of the switch. And then a router allows different networks to connect to each other. So basically, if you think of your router at home, it allows your home network to connect to the internet, which is also just a global type of network. So a router allows multiple networks to connect to each other. A switch allows multiple devices to connect so that we can create a network. And a modem changes the type of signal we get. Nowadays, your router that you've got at home has actually got all three of them built in, because you've got a small switch so that you can allow multiple devices to connect it. You've got a modem that will change the type of signal, and then it's a router that allows your home network to connect to the internet. So please don't get confused with, because nowadays we say at home you've got a router. It's not only a router, it's actually all three of these technologies combined. And the word they use for that is convergent devices. Okay, there's some nice activities. Okay, overview of network innovation. So there's things we get. First one is VoIP, Voice over Internet Protocol. We use that nowadays when we've got our Skype classes, or our Discord, or when we use Zoom. All of them uses VoIP, Voice over Internet Protocol. That allows us to talk over the internet. We get our virtual private networks. That's what a lot of companies use now, so that they can work from home. So a person can be at home and then connect to the company's private network and work as if he's sitting in his office. So the definition for a virtual private network is connecting to a private network using a public network. Remember, the internet is public, so we're using the internet to connect to our company's network, which is a private network. You'll see there's some new words. Mesh, a type of network in which a device transmits its own data as well as serves as a relay for other devices. So this device will connect other devices. It's sort of like in our ring topology that I said. So each computer will send on the other computer's work, but it will also send its own one. And then they talk about the mesh, and our virtual private network I just spoke about. So there's our VoIP that we can talk. Then there's three words. There's the internet that we know, but then there's the intranet and the extranet. Okay, we need to know just the difference between them. The internet is our normal public network. So it's a network across the world where anybody can connect and share information. An intranet is when a company uses sort of like internet technologies like websites and stuff to create their own internal network. So an intranet is, it looks like the internet, but it's a company's private network. That's also got pages for the different departments so that they can share information and send information and all that. but it's only for the company itself. Nobody outside the company can use it. And then an extranet is if a company has got something like an intranet, but then some of the information they want to share with other people. So let's say it's like Coca-Cola. They could have an intranet where they just work for their own things. But now they realized, oh, but they also want the distribution company. Let's say they've got other people that distributes their product. And maybe they want all their suppliers, all the shops and stuff, so that they want them also to connect to the network so that they can see the current prices and the current news, what's happening in Coca-Cola. Then it becomes an extranet. So extranet is similar to an intranet. The only difference is it's not only for the company. It's for the company and some other selected people or companies that could also connect to their network even though they're not part of the company. Okay. Virtual private network, I just spoke about now. When we use our internet to connect to a private network, they use passwords and firewalls and stuff to protect still their own network. Then we've got location-based computing. It refers to several different technologies that make use of geographical position to customize a user experience. Okay, so that's like our GPS, even mobile phones and all that. Because a lot of these things, if you even nowadays, like with Uber and some of those cell phone apps, as soon as you get to a certain place, geographical location, you might get certain ads that applies to you. So, and also like your weather, if you allowed your phone to access your location, as soon as you go to the weather app, the first weather you'll see is actually the weather patterns of what's happening at where you are right now. And that has to do with this. So your ads and your information that you get and everything is based on your location. Okay, then social implications. So social implications, let's go see what they say here. Main thing behind social implications is we must just remember everything we do with technology also has got other implications that could be negative to the people around us and everything around us. Okay. Chapter, there's not a lot of facts that you must learn. So you can read through this. Everything's got that negative part in. One of it is this location-based computing. So you must now remember that people could use it for negative purposes as well. So you can see use your common sense before buying into the hype of location-based apps. So, but common sense nowadays in computers is very important. So let's look at what they say. Stalkers and pedophiles will like these apps because they will know exactly where you are and what you want. If it is anywhere on the internet, consider it public. Remember, once you post something on the internet, you can never take it back. So it's very critical to think about what you do on the internet and what you post. Your circle of friends is much bigger than you think. So on Facebook, even though you think you've only got those 5 friends, remember they also share with other people, and then there's other people that just also go visit them. So there's a lot more people that actually read your information than those that you think do. We must know we all make mistakes, so don't be too hard. People lie, especially on the internet. That is very true, so you need to take care of that. Small pieces of information add up. So small things that you put on Facebook and other small things you put on Twitter, people that tries to stalk you will actually go to all those places and gather all these different things. And a lot of times they can actually then deduce where you stay, what type of things you like, what type of shops you like to go visit, which grade you're in, and all those things, even the school, because of location-based apps. No, you can't have separate online and offline lives. Okay, so you should not, just because you're online, think you're a different person and then do nasty things and stuff and think it doesn't matter. Your morals still need to apply to what you do online. You can't predict all the ways these things can work against you. You will never know what people could do. You could maybe say something good, but because it's on the internet, you must remember there's no. When you post stuff, you don't have. People can't see your body language and your, which includes your facial expressions and everything. So sometimes something you might not mean in, in a bad manner could come across like that. So you see there, and then the price of ignorance. Don't trust things on the internet lightly. You must go see nicely what, especially like they mentioned their free services. Most of the time, people won't just do things and post things to be free. There's a lot of times there's some reasons behind it. Why do they want to do this? How to locate a missing person by tracking their cell phone. I think all of you know nowadays, even if your cell phone gets stolen, you can track my phone and stuff. So that could be used. And then ethical and legal issues of network use policies and practices. You must remember, even when you install software, that initially when you just click accept, 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 there you accept it actually to a legal document, and they can hold you accountable for whatever said in that contract. So you need to take care of what you agree to and what not. Capabilities and limitations of ICT. So computers can perform tasks very fast. Some CPUs can execute literally billions of instructions per second. Okay, but portable devices such as laptops, PDAs, mobile phones are limited to their battery life. So you'll see there are some capabilities and then some limitations. I think that's easily to be read through. And that is until where we're going to go for this week. Okay, the homework I'll also post here, so if you can just do that for me, please. Thank you very much, everybody.